Yeah, I know a lot of keynote are usually some kind of a visionary statement, and this particular vision really was started out by a gentleman named Mr. David Cohen. Dave Cohen. He was a um, leader, visionary person at the at NavAir. And if for those who don't know what NavAir is there's three different Navy groups. There's NavSea, they build the ships. NavWar, they actually do a lot of other kinds of communication systems and things, mission stuff. And NavAir is the ones who build the air vehicles that actually have to land on the ship. So that's been our sponsor since 2013. And we also work with the Army, and I have one slide from the Army below, but Dave's vision was to transform systems engineering. He wanted to blow up the traditional V model, if you know what that is. So with that, let me get going here. I just want to put a disclaimer out there that it's like, yes, I'm from Stevens, and I work with the Systems Engineering Research Center, which is a collaboration of 25 universities. And so while we may like the tools, we are not trying to suggest our sponsors actually advocate them or not, but they might. Systems engineering is a team sport, and yes, since 2013, we've had a lot of collaborators from various universities being part of our team. So while I'm up here talking about this, there's been a lot of people that have participated and done a lot of great work over the few years. So to get started here, again, I'm going to go back to the context of what we've done, and what we try to do is to build this surrogate called Skyzer. And so what you're going to see here is, and a lot of times a vision statement might say, well, this is the idea of what we're going to do, but no, we actually made these things. And so I'm going to be talking about things that have been made, or I'm trying to get them to be released, which is in military terms, it's referred to as distro A, which is publicly releasable. Everything that you see here today is publicly released, so that's not a problem. I'm going to first actually talk a little bit about some digital engineering measures that we use to correlate some lessons learned over the pilot actually ran for about 3.5 years. Okay, and so I'm going to talk about specific things about how we model everything to demonstrate the art of the possible. We come up with what is an authoritative source of truth. I'm going to explain to you what that is, along with the actual environment that actually are the elements that supported working in an authoritative source of truth, which one of that is the OpenMBEE. I'm talking about this concept of a full stack of technical models that actually link to other types of models, such as stakeholder analysis models, which could be things such as cost models or airworthiness models. And there are some distro A videos out there that you can go look at. The importance of modeling methods. In other words, you just can't just necessarily take a set of tools and just start using them in any way. You really do need to apply modeling methodologies, and it includes modularization methods, as well as methods for describing specific artifacts, which will lead us to what's called digital sign-offs. And in the military world, they had this term called a CDRO, which is a contract data requirements list. We're going to talk about how to transform and actually do digital sign-offs directly in the view editor of OpenMBEE, and that's one of the things we demonstrated. Again, one of Dave Cohen's objectives is also to eliminate CDROs, but that wasn't necessarily what we wanted to do, so we transformed them using digital sign-offs. I will talk about that too. And then we also did a little work with that we can talk about, which is using ontologies to actually link back to technical data that is in SysML models, and we used OpenMBEE to begin with to actually do that linkages, that link. Again, and everything that's come out of here is being transformed into workforce development because engineers like examples. All right, so I hope we're tracking along there. I'm up to slide 5. All right, so one of the things we did is that we first went out and did a survey starting in like 2014. That's when I met Robert originally out at JPL. And Dave Cohen was saying, tell me about the most advanced holistic approach that you've ever used to model-based systems engineering, model-centric engineering, model-based enterprise. We said, yes, tell us it all. And when we went there, because we showed up I was a researcher. I was under non-disclosure agreements with almost all of the organizations. But because we had a Navy sponsor show up, they brought the best and the brightest. So they were telling us about the most fantastic programs. We did 21 initial visits. We made many more after that. And in 2000 and late 15, they decided that, look, people that are really advanced here are moving very quickly, and the Navy must actually transform, not just evolve. And so in 2016, they came up with this systems engineering transformation plan. And one of the things that came out of that was the idea to actually do a surrogate pilot. And that was related to, or at the time at which there was a hurricane. And so they decided the search and rescue would be a good surrogate mission. Right, so there we basically came up with a UAV, and Dave Cohen was also concerned about blowing up the V and actually not being able to do multi-physics design in this new kind of world. So therefore they picked a particular vehicle that is like the Bell Eagle Eye, which is actually in the museum out at NavAir, and they wanted to fly fast and fly far. So therefore that was one of the things we worked on. So we did a number of phases. First thing is that we had a surrogate contractor, Altair, who was from the automotive domain. And the reason why Dave picked them as a surrogate contractor is because he felt that somebody not in the defense domain might actually be able to bring some new ideas that would go faster. And so they also had multi-physics kind of tools. So we did some multi-physics analysis, finite element analysis, to looking at the air vehicle shapes. In the next phase, we worked on another concern, which is how to actually have two interacting capabilities, both the ship and the actual air vehicle land on the ship, and that addressed a stakeholder concern of airworthiness, which is how do you get a flight clearance? And then the last one that we've been working on for the last year is cost modeling, and we went back and revisited how to actually do that, and I'll have more to talk about that in a minute. All right, so one of the things that also occurred is that there was another research task that actually looked at a large number of people. I'm actually going to be having a paper that should be coming out in INCOSE Insight that actually summarizes this particular analysis. But there was a study done, the individuals, and they, as well as reading reports, and they came up with 22 success factors or measures. And what I did is I correlated that to the lessons learned that are in the NavAir or the surrogate pilot reports that I put up there. And so what you see here is at the top 6. And so one is, and these are some of the things I'll go through, which is establish the integrated modeling environment or digital engineering environment and the authoritative source of truth. We used OpenMBEE to do that one. We demonstrated that it was technically feasible to actually model everything. And what we found is by doing some of that, we eliminated some things that were traditionally required as CDRLs, which are, again, these documents. And we also showed how we could transform away from CDRLs using digital sign-offs in the view editor of OpenMBEE. We basically showed how to align with the modeling methods and how artifacts are that are defined, say, in SysML types of models can be used as the criteria for digital sign-offs. And then we also talked to industry and got a lot of buy-in in the sense that they'd be definitely willing to actually transform. And as Robert mentioned, both Lockheed and Boeing use the OpenMBEE. And why do they use it? When you actually go out and talk to some of their leadership, they say it establishes a nice ecosystem that can be extended, and we completely agree with that. So this is a roadmap that we created. The original concept came from Airbus, but we used it. The idea is that if you look at the time here, and as you move up the roadmap, there's usually many things that are actually of interest that you're looking at. And so this is described a little bit more in some of these other CERC documents. But we also want to align it with the digital engineering strategy. So there was 5 strategic goals that were created in 2018 that was released: decision-making, authoritative source of truth, technical innovation, collaboration, and digital engineering workforce. And so I like to use this to actually tell a story. So if we think about MBSC, it really strengthens system engineering. And because of SysML coming in, in 2006 around there, it really is quite a while ago, but it's a technical innovation that really helped. Another thing that we did is that we picked up OpenMBEE, even though there was the Teamwork Cloud, but the OpenMBEE and using the model management system turned out to be so much better, and it gave us a lot of things that we learned. We also established an authoritative source of truth. or collaboration and decision-making, as we'll talk about in a minute. We actually showed how to transform away from just process models to also have methodologies where we can actually describe specific MBSC artifacts that can be used for digital sign-offs. In our Army work, we also brought in ontologies and semantic technologies so we could link basically these descriptive models with multi-physics kind of model and do much more, a much greater amount of cross-domain model integration and simulation. And that gave us the semantic integration that we're looking at. I also worked on a project where we actually used the ontological representations along with machine learning to look at digital twin architectures. And that was just another research task that I'm not going to talk about today, but the reports are out there. All right, so again, this sort of reflects going backwards on what I was saying is that if we look at first that, MBSC really strengthens systems engineering and the fact that we don't just describe requirements, we actually describe the structural analysis, behavioral analysis, looking at the interfaces that all relate to the requirements. And it actually is done at different levels of abstraction. So there's different methods that should be applied at the systems level versus the mission level. And we were able to leverage DocGen, which is part of OpenMBEE, to actually generate stakeholder relevant views. So therefore, a lot of stakeholders may not actually navigate what's called a containment tree for all of you that understand that. And so then we also formalized how we represent information in an authoritative source of truth. We also showed how when you have an authoritative source of truth, you can actually have a collaboration environment so that the people can actually look at specific information based on the methodological guidelines so that they can support decision-making based on very concrete pieces of information. And again, taking all that, we've been able to leverage it and actually send it back to NavAir where they're actually turning it into workforce development. So Dave Cohen's concept was one of blowing up the V's, but he talked about it in these 4 element levels, which is mission models, system models, contractor models, and we talked about it as being very iterative kind of a process. But as you see here, they're at the mission level, it's about capabilities, and the system level, there's a functional logical view. So when you're with a company like or organization like NavAir, they usually do not describe the detailed analysis. They actually stop at the functional logical models and then let a contractor elaborate it. A little bit different for the Army, but that was his concept of this framework. And so what we're going to talk about is mostly the things that come down to this particular line here, the functional logical, but a little bit about what we did to simulate the contractors going forward. All right, so a lot of people, this is a very old chart that I have, but I recognize going back that a lot of people don't really necessarily understand what I meant by the artifacts. All right, so notice, just read whatever's in this, actually the blue thing. So if we have a high-level set of requirements, and in SysML, we can actually model those requirements as blocks. And normally from the higher level of refinement, you end up also getting a set of requirements, but also a set of use cases. And so if we go through the analysis process, we can actually look at behavioral analysis or instructional analysis. So think about the blocks that might occur, the parts that might occur from there and their interfaces. But also, we normally work in parallel. So we don't just do structural analysis. We may do behavioral analysis at the same time. So from an activity diagram point of view, it allows us to look at the processes, the asynchronous concurrent processes, but also because it's control flow and data flow, we might actually be it might inform us about our interfaces that exist in the structural point of view. We also may refine use cases as, say, sequence diagrams. And this might be good for software or communication systems. We might also refine use cases as state machines, which is the UAV is in the hangar, they roll it out, it takes off, it flies its mission, comes back, lands, goes to maintenance, goes back to the hangar. We also can describe abilities such as fault trees for hazard analysis. I'll give an example on that in a minute. But we also, for the actual blocks up here, which so therefore in a block definition diagram, there's like part properties and value properties. So some of these value properties, well, they can describe constraints on, say, the air vehicle, such as our desire for it to fly at 180 knots, or and so you can describe those kind of constraints in parametrics. But in reality, what we've done, and we've done a lot more of this for the Army, is that we're now able to actually link that information to much higher fidelity kind of information, such as computational fluid dynamics that will really provide us information into the aerodynamics, as well as, say, like using finite element analysis, which is to understand the structure of an air vehicle that must actually land on a ship and 80 knot winds carrying a payload. And so therefore, while we might have wanted it to originally be 180 knots, in reality, we might find out that given the weight that we have to add for it to be able to land on a ship, it might actually only be able to travel at 170 knots. So that's higher fidelity analysis that we want to link with into these models, and they will inform us about the actual value properties in these blocks, which will actually turn out to be used in the next set of requirements. All of this information also provides us verification information for both planning purposes and execution of the verification. And so with that, that allows us to look at the next level set of requirements that can actually be traced to the higher set of requirements. And so what Navier realized is that they don't actually just have to give the requirements to the contractors any longer. They can actually give them all this structural and behavioral analysis that went into actually going from one level of the requirements to the next level of requirements. So that if the actual, say, a contractor, whether it's during execution of the actual contract or ahead of time, sees that there's an issue with the requirement, they have all the rationale that went into it. And that is a big change with the way that we've explained it to Navier and how the contractors already understand that. Right, so with that, given that you understand those layers, I'm going to explain the authoritative source of truth. So we have this full stack of models. So we have a mission model, and we leveraged model import mechanisms called project usages in the No Magic product. So the launch recovery system on the ship, it actually links to the mission model and the requirements and constraints. And so does the Skyzer model, and the contractor model also links, just as I was talking about before. And we have means for actually linking to these component models too. So let's just assume that we actually have some kind of particular situation where the launch recovery system needs to be changed, and it actually affects a constraint in the mission model. Well, now that's visible all the way down to the landing gear. And that is what we're talking about in terms of the authoritative source of truth. Now, there's at least three kinds of reference models, or some people call them reference architectures. We have one is a process model that was actually evolved. It's called the Navier Systems Engineering Method. It not only describes processes, the guidelines of what we're trying to look for, but also the methodological artifacts that they would like to be captured, the how of it. Now, there's also these other kind of models that are referred to as stakeholder analysis models, and they come from other kinds of standards, such as capability-based test and evaluation, or mission-based test design, which was a standard for Navier, but also things that are maybe more understandable to you, which is military standards, or standards such as airworthiness, which is MIL Standard 516C. And so at any particular time, what we're doing is we're creating a specific instantiation of one of these reference models that is a subset of the information needed for flight clearance that's based on information in the technical stack. Okay, we did the same thing with cost models. This is based off MIL Standard 881E, and it's being formalized by Navier. And so now let's go back to our scenario that we were just talking about. So now what happens is that if we actually had a change that was potentially recommended on the ship to actually change something that might affect the landing gear, now all of a sudden we can actually say that, oh, wow, that might have actually caused a particular additional verification constraint for airworthiness, which means that we have to have another test. But now that we're actually linking the cost model through the airworthiness model, we're being able to see that, oh, wow, if I make this change to the ship and it actually affects all these particular other elements, then I understand its cost. So now decision makers and basically in the acquisition world can say, well, do we really need to actually have that particular requirement? Maybe it's that it's I can only have a 20 feet per second versus 25 feet per second descent with an electric landing gear. But if I needed it really to be able to be 25 feet per second, then I'd have to have a hydraulic one. And so therefore it adds more weight, which also means that I might actually not be able to fly as fast and as far. And so all these decisions can be made up front, and so they can decide what's going to happen. This is the authoritative source of truth in terms of the models. The other thing we actually were able to demonstrate is the cost constraints that are associated with these models, which are done by parametrics. We want to be able to release these to organizations, but we don't really necessarily want them to actually know the true cost, because Navier, for example, it knows different organizations have different cost constraints. And so we're also able to demonstrate through automation that we can automatically switch out different kinds of surrogate equations with real program equations. So this would allow, for example, Navier, what if analysis to actually look at two different source selections as they're actually looking at the particular proposals that come from organizations and to manage programs in a very different way. And then the last kind of a reference model, sometimes referred to or previously referred to as probably as reference architectures, are things such as generalizations of prior designs. So in other words, a system reference model might also describe the various kinds of UAVs. So therefore, we can instantiate those particular models very quickly and maybe come up with a 60 or 70% solution. But notice, we're also partitioning those reference models in terms of both missions and systems. And that's the kind of recognition of things that have been understood by us during these pilots. All right, so that was the reference models. Those were the models we captured, okay? They can be done in various kind of tools, but we also instantiated a particular set of tools. And one of them was obviously the OpenMBE. And so think about this is that we actually use the view editor, model management system, Teamwork Cloud. And while we actually did try to use Cameo Collaborator, we did not find it to be as nice to use as the view editor. And we know that there's other things being actually modified down the road. But yeah, so these are the elements of the system. And so how would this work? Well, let's just say we go back to that, a different kind of constraint that says that, I have to have a endurance in Skyzer of 50 hours with a threshold of 2 hours. Well, let's just suppose that the contractor said, well, under weight and environmental conditions, a threshold of 2 hours is not possible. It has to be 3.8. So if they have the right authority, the people from the contractor could come up and actually use the view editor, log in, and actually attach a comment and a URL to the analysis such that then the subject matter expert from, say, Navigator could come up, actually hyperlink into the environment of the contractor and see, oh yes, I see through this analysis that it's not possible to have 2 hours, so therefore they can actually branch the model, okay? And so yes, we're talking about model management capabilities. Actually change the 2 hours to say 4 hours, okay, from the threshold, and then actually get a digital sign off on it, merge it back into the trunk, and then actually synchronize it back into Teamwork Cloud. That's the scenario. So this is how the tooling works, but we did that. There's a number of videos that actually were released on how that occurs, but this is not a tree, or this is not, okay, it's not a hierarchy, this is a graph. And that's what an authoritative source of truth will be. It'll be a distributed set of information. So let's go through that scenario. Suppose this is the Joint Strike Fighter program, the F-35. This is Lockheed, and let's just say that this is Rockwell over here, represented by Stevens. So it turns out that the government has a relationship with Lockheed for building the air vehicle. The government has a relationship with Rockwell for building the helmet, and there's a relationship between, say, Lockheed and Rockwell. So that's why the future is going to look like things in this authoritative source of truth will be a graph. All right, so here is the OpenMBE picture, and one of the things that was very valuable to us is that I know that historically when I've talked to Chris Delp many years ago, he was saying that the first thing that they really needed to do was to actually have a better model management system so that they could actually do model management down to an object level, as I was mentioning, like that threshold value. But also, he recognized very early on that it's a lot of subject matter experts were not going to be navigating the containment tree. And so therefore, DocGen was created to be able to do that. So I'm going to talk a little bit about how DocGen works. If you're not familiar with it, it's you embed a particular view inside the model and it'll generate it to a web browser kind of a view. All right, so let me first start out with a little bit about the Navigator systems engineering method. So they had a set of processes that they were actually doing, but what we said in our review is that you really need to talk about specific artifacts being produced for these particular steps in the model. And what Skyzer does is that we modeled it based on the mission requirements, the functional logical models that were described in the Skyzer model, but we also described while Navsem allows Navigator to describe a specific set of physical constraints, such as a radio or a specific engine. We basically showed them how we can separate those kind of views so that we keep the actual functional logical in the Skyzer model, which is what's been done, and the physical stuff is actually done in the contractor model. So not that the contractor would necessarily use Navsem as a method, but that's what we did to demonstrate how it works. But the other thing we did is we actually showed how to add digital sign-offs for specific artifacts. So for example, on this particular one, so the selected operational use case actually comes from the mission model. So therefore, that's how it's linked in. And I guess linked in through project use cases. And what the contractor or what the actual subject matter expert would do is sign off on the selected operational use case. All right, so how does that work in terms of DocGen? Well, we end up having the DocGen elements, which is a document. Okay, we actually have a view, which this ends up being a placeholder in the model. And with that, we have allowed the modeler to expose model elements from the actual SysML model. So it's not imposing on the modeling team a specific structure, although that might be nice. And then what we do is that we have these viewpoints. Viewpoints are like a little program where it actually grabs the information, say like tables or images, or in this case, digital sign-offs, out of the actual, from the exposed model element, and actually places that right at the view. And that is how we did it. So one of our examples is here is the selected operational use case. And we created a set of templates for digital sign-offs where we can do the sign-off, it'll be approved by, and we could add other information such as, completeness or other comments. And I'll show an example of one of those in a minute, which is with this one. So we have another example of a digital sign-off for, say, fault tree analysis. Okay, and we will actually have the fault tree. Here is the template. Notice that this one is different than the other one. It's still got the approver, who is approved by, but also now the probability impact mapped back to a traditional kind of a risk cube. And I use this example because I'd like to explain a little bit about why I like requirements blocks in the model, and actually so that they can have associations. Here's a fault tree. So fault tree is a way to represent hazard analysis. At the top, I have a possible hazard that could occur, and if it manifests, then a mishap could actually occur. So you build up this and/or tree, and at the bottom, we have these things called basic events. And what we want to do is that we would actually want to create a mitigation requirement for a basic event to try to say that if this event actually did occur, we would want to do something to actually try to preclude any kind of an event, basically a mishap from occurring. So that's an important reason why we, in these requirements, they don't come from some kind of a functional decomposition or any kind of a decomposition of requirements. They're derived from the analysis. So in this particular case, we want to show that this particular artifact was actually rejected because they believe the actual subject matter expert believed that there may be a basic event missing. So one of the questions that was occurred from subject matter experts was, well, gee, if you actually do a sign off on an artifact and then it actually changes, is there any way to automate basically going back and saying, oh, I need to really redo this digital sign off. So maybe if it was approved, I want to do a TBD, to actually turn it back into a to be defined or to be reviewed again, I can do that in an automated way. And yes, we actually found a way to do that. And so we have videos actually on how we did that. But what's important is that, so notice this one is a good one too, because this is a rejected. So in other words, if someone came back and then they added a new basic event and another mitigation requirement, we would want to be notified immediately that it's time to actually review this particular artifact again and do a digital sign-off. And that's what Dave Cohen wanted to do. He wanted to get away from the monolithic reviews called PDR and CDR, and he wanted to actually have a design review a day driven by the continuous maturing of the actual analysis and design. So then the other one that we've done, there's this infamous thing called a section L, which is as part of an RFP response, and what it is it's a technical evaluation criteria that should be satisfied by the response, request for proposal response from any particular contractor. Well, what we did is that we showed how we can actually have the contractor embed this table directly in the view editor, and this is an image of the view editor, and we actually had our subject matter expert, Don Plotkovich, that actually had never navigated a containment tree. He didn't even take any SysML courses, and he simulated the source selection. So this is part of the source selection technical evaluation. So just another use of actually embedding digital sign-offs directly in the model. And then, so where are we? So we're not done yet. There was a lot of things we didn't finish. One of the things was exactly this one, which was that how can we actually, what are the different kinds of templates that we would want for digital sign-offs? How will we potentially like transform away from traditional monolithic reviews, PDRs, CDRs, and obviously in our today's work, the way that we've actually transformed and doing things like this particular conference, which is online, a gentleman named Greg Page came up with this concept of a baseline progress measures, which are going to use the measures and metrics that are related to these digital sign-offs as part of actually computing a maturity. And so what these used to be based on, which was a thing called the Systems Engineering Technical Reviews, or setters, what we found is that there's a number of different setters that are just completely subsumed in the way that we do new work with the authoritative source of truth, with the environment. And so therefore, a lot of work still would need to be done. We didn't get that far in this Geyser project. All right, so the last picture that I'm going to show is how we use semantic technology. And again, with our full stack of models again, but for our Army work. This is a little bit different. So from the Army reference models, we have been building ontologies. And also this is a distro A slide here. This is one of the very few ones that I have. We also describe the mission models, which actually relate to a graphical ConOps, which we actually use the Unity gaming engine to actually do that graphical ConOps. We have a system model, and then we have a systems analysis model and we use an ontological based approach to describe information that's coming from, say, computational fluid dynamics, finite element analysis, even say like 6 degree of freedom, the actual trajectory that the particular projectile is going to take. And we do a lot of co-simulation of that and map the information, the metadata, back up to the value properties that are in the analysis model or to the system model, or all the way up to, say, mission measures. And so those pictures that I showed you in the very early on about how we can actually use high fidelity information at these lower levels, and semantic technologies is how we can actually bring that information back into our models. And again, yes, use view editor and digital sign-offs for all those things. And with that, I'm sort of done, except that I can actually show you that I just want to share that these are the set of models that we've actually collected from Geyser. A lot of models. So that's what I'm saying, that we have a lot of information that we've collected. This turns out for being the capability-based test and evaluation model, but this is just a rendering in the view editor of one of our actual models. Here's another one. This is one where actually I had the digital sign-off, as I was mentioning down here earlier. So, and with the view editor, you can just click on that and then be able to click on a particular block. Yeah, come on. It'll actually open up in a minute. But with that, oh, there you go. So then I can actually just put my sign off in there and do the assignment. So that is it. And with that, Robert, back to you.
Very nice, Mark. You never disappoint. Very nice presentation. Okay, do we have any questions from the audience? Shireen, how does it work? Is everyone able just to unmute and ask questions, or what's the mechanism here?
Yeah, they can just raise their hands, like digital hands, or they can write in the chats.
Okay.
Have any questions? Yeah.
Okay, there you go. Anyone?
So yeah, Mark, Robbie here. I have a question. I mean, this is incredible, and I was actually, chatting with Robert and saying it would be amazing if something, such a massive change could get implemented on these big government programs, because it seems so much more efficient and effective. So what are the kind of like next steps for the technology really? I mean, is there, case studies or actual implementation on a smaller program? And it just seems like there's a lot of, the entire system and the skill sets of those people that are running these projects or managing these decisions, currently participating in design reviews, are used to doing it a very different way. So kind of what does the transition look like to, to actual implementation?
Yeah, so that's why we actually worked on the cost models, is because the people at NavAir, the gentleman that took over for Dave, his name is Jaime Guerrero, felt that it's what we needed to do is to actually have cost models so that the program, program managers would actually adopt it. And so there is adoption by a few projects or few programs. Like Aura is really following along with this. Aura is the future vertical lift. But I agree with you that it's like what we really need to do is to make people aware of this. People are not that aware of it. I'm actually giving a talk this week too to the chief engineers from the DoD about what we're doing here. We've also talked to the acquisition community. There's a new consortium that's related to the CERC, which is called the Acquisition Innovative Research Center. And so those are the decision makers that on my picture that I showed you there, they need to understand that we've already done a number of this and they can make decisions based off of linked models as opposed to documents. So I feel like we're right in the midst of a transition point right now. So, but I think you are with the Air Force, or we're with the Air Force. Is that right?
We are doing R&D projects with the Air Force. Yeah.
Yeah. So like a number of Air Force
we're part of the standard review process, and you do a review with the customer every 6 months or something. And yeah, it's just, this is a much better, more, better system.
Yes. And actually industry has already reached out to us. I actually am working on another research project that is actually telling industry to actually understand that the way that the DoD is going to actually ask them for information in the future is going to be very difficult. So if they get on this earlier, then there'll be a leg up.
Yeah, that makes sense. Thank you.
I see that Bjorn raised his hand. What's your question? I guess. Yeah.
Actually, I have two technical questions. They are quite linked. So you showed a lot of linkages between your models, so models that are related. I was asking myself how this is realized. So are the links created manually and is the information transported manually, or are there some conversion algorithms or model transformations in between?
These particular linkages are based on using project usages in a Cameo SysML model. So in other words, the Skyzer system model does the project uses of the mission model, and inside that's now visible to them.
Mm-hmm. Okay, understood.
Yeah.
Thanks.
So I know some of the tools do not necessarily have that capability, but yes, we did take advantage of it.
You had a second question you said, or was that also answered?
No, that answered both questions.
Okay. Hassan, you raised your hand as well.
Yeah. Hi, Mark. I had I think same comment on the project usage. So we actually at Ford have been using this, and we find it quite difficult to use project usage for large number of projects. Did you have any performance issues on that?
It does take longer the farther you go to actually load these kinds of things, and maybe we're not maybe doing stuff at the scale that you're doing it. So I didn't see the issue of the performance on our projects.
Okay.
Yeah, because obviously cost model would be the one that would actually load the slowest because it has the most project usages.
Yeah, maybe we can exchange notes online on how we are doing this. I'll talk to you after. Thanks.
Yeah. Well, the other thing too is like if you use a lot of profiles, that will actually, if you have a lot of stereotypes and you actually have to load a lot of profiles, that will actually have a negative effect. The other way you can do that is you can actually make a block that actually is inherited by all the blocks, and you can make it say like an enumeration. And so therefore, if you want it to be stereotyped, you can create a value property that effectively does what a stereotype would do, but actually allows you to have far fewer things that are actually loaded. I don't know if that could be your problem.
No, I think it was more related to if we have one project that's referencing multiple other projects and multiple, beyond 10. So
maybe you can take that offline because I have another last question from Marcel.
Okay.
Yeah.
Okay,
So
Marcel.
Marcel,
Ask yourself, or I should read it, Marcel?
I'll read it. It says this: can you comment on the customer acceptance of the key review milestones being replaced with digital sign-offs? I cannot really say too much. I mean, although, I mean, I would say that we've had a number of meetings where we've had both Lockheed and Boeing, and they've actually seen that we were talking about doing that. I didn't get any negative, but it's like putting it at, the more important thing is that what you have to do, and this is what we now know, is that you have to actually create different statement of work language that actually says that the contractor needs to be able to support digital sign-offs and or permit a subject matter expert like this particular chart here to be able to navigate into the contractor model. We have had RFI responses to like an adoption of those kind of things, and several of the organizations all were like for it. And I'm not sure if they were for it because Navsem was asking for it, or if because they actually had a way to figure out actually how to already do this. So I know that's maybe not a complete answer. So in other words, I haven't had a chance to talk to them about it recently.
Okay. Okay, I think we have to move on. Thank you very much, Mark, for the great presentation, also for the questions.